Okay, problem number 3 from the 5-1 notes. Now, here is the slope formula. What you do is you take y2 minus y1 and put it over x2 minus x1, as long as x2 minus x1 is not 0. What? Here's what I like to think. I like to think of the change in y over the change in x. There we go, make it a little bit better. Remember, change. You take the new thing minus the old one. These x2 and y2 are the new coordinate points, and then 1 and 1 are the old coordinate points. So what are you talking about? Well, here's an example. So here's their formula, okay? So here's the new coordinate point, and here's the, oh, sorry, I take that back. Here's the old one, my bad. That's the old one, here's the new one, okay? So here's the first one, here's the second one, the old one, the new one. Now what they're trying to do is, here's x1, here's y1, here's x2, and here's y2. So they want you to plug it into this formula and do a whole bunch of stuff. I hate this formula. Okay, they do it right here. Here's your y2 minus your y1, x2 minus x1. You get negative 2 over 4, and your slope is negative 1/2. Great. Here's what I do, friends. Okay, and it's some gridded response. Okay, cool. Here's what I do. So what are the coordinate points again? It's negative 1 and 0. And then it's 3 and negative 2. I draw myself a little, I call this the loop-de-loop method, okay? Here's what I do. So I think this, change y over change of x. So I ask myself, how do the y values change? And then how do the x values change? So I make a little loop from the y values, and then I make a little loop for the x values. And then I just put those numbers in a fraction. So going from 0 to negative 2, what did you do? Well, you lost 2. Going from negative 1 to 3, what did you do? You added 4. Weird. Negative 2 over 4, negative 2 over 4. And then remember, always simplify your slopes. There you go. Okay. I'm not knocking the formula. I'm just saying it's really confusing to put these 4 coordinate points in the correct 4 spots. This right here, the loop-de-loop method, super duper easy. Again, change your y over change of x. Change your y over change of x. Tell yourself that 1,000 times, and you will never mess these up. Here we go. What's the slope through these coordinate points? Again, the question was, can I just graph these and then look at them? Yeah, of course you can, but that's a waste of time. You can find the slope in a matter of seconds. So again, change in y over the change in x. Blank fraction bar, let's put my information here. Going from 3 to negative 1, looks like I lost 4. Going from 1 to 4, I gained 3. There you go. Negative 4/3 is my slope. I'm done. I got nothing else to do. Of course, you can graph those points and waste a whole lot of time, but you don't have to. Okay? Change your y, change of x. Change your y, change of x. How did it change? Add or subtract. How did it change? Add or subtract. Write those numbers down. Boom. Slope right there in front of you. B. Plot the points in part A and draw a line through them. Does the slope of the line look like you expected it to? It's the slope of negative 1/2, right? Well, let's go ahead and sketch a little graph here really quick. I'm going to use this line to help myself out. See, the coordinate points were negative 1 and 0, so you go there. 1, 2, 3, and negative 2. Excuse the bell. Draw a line through them. I'll try to draw a straight line best I can. Okay, not too bad. Oh, look, it's a picture. Sweet. I wonder if I can figure out what the slope is by looking at the picture. Looks like it goes down 2, and then it runs 4. Weird. Rise over run. I wonder if that simplifies to negative 1/2. Yeah, it does. Okay, so yes, you can plot coordinate points, and then you can look at the physical movement with the picture, or you can figure it out with change in y over change of x. This goes so much faster than plotting coordinate points and looking at the picture. Okay, so use a bit more brain power here with this nice little loop-de-loop trick. Okay, that is problem 3. All right, peace out.